Okay, let's dive right into this explainer. Today, we're unpacking a massive story, how one of the most powerful tech giants in human history completely lost its footing. We're talking about Intel. For decades, you know that little Intel inside sticker? It wasn't just a marketing gimmick. It was the absolute, unquestionable stamp of computing power. Their chips powered almost every computer on the planet, and their manufacturing systems were literally the gold standard of the industry. But here's the crazy part. Their stumble wasn't caused by some sudden, overnight disaster. It's actually a super fascinating story of gradual operational bottlenecks, incredibly complex planning errors, and a slow, agonizing loss of execution. Let's get into it.
So how exactly did the undisputed leaders stumble? It's a fascinating mystery, right? How does a company with virtually limitless resources, a company whose name was practically synonymous with silicon innovation, find itself struggling to just execute? Well, in the semiconductor industry, manufacturing speed and production capability aren't just background tasks. They're your main competitive weapons. If your manufacturing slows down by even a fraction of a percent, your entire strategy is instantly at risk. Because in this business, standing still is exactly the same as moving backward.
Act 1. The Untouchable Giant.
To really understand this, we have to look at Intel's historical superpower, vertical integration. While other tech companies were slowly starting to separate the design of their chips from the actual building of them, Intel relentlessly did both. They combined world-class chip design, unmatched manufacturing expertise, and massive, large-scale production capability all under one single roof. Just think about the synergy there for a second. When the engineers designing the chips are working right down the hall from the engineers figuring out how to print them, you create this incredibly tight microscopic feedback loop of innovation. For years, this gave them a major strategic advantage that competitors who relied on third-party factories simply couldn't touch.
Now, we have to unpack why chip manufacturing is widely considered one of the most insanely complex industrial processes in the entire world. I mean, we're talking about manipulating matter at the scale of a few atoms. It requires absolute extreme precision. You need massive capital investment. We're talking $10 to $20 billion just to build a single fabrication facility. Then you need highly specialized equipment, things like extreme ultraviolet lithography machines, which are these engineering marvels that only a handful of companies on Earth can even build. Add to that years of continuous technological development. In this mind-bendingly complex environment, even a microscopic delay can trigger massive competitive consequences.
Act 2. The Impossible Balancing Act.
Right at the center of our story is capacity planning. In the semiconductor world, you can't just flip a switch to crank out more chips when an order comes in. Preparing production capability for future demand has to happen years in advance. Building an advanced fabrication facility takes years of agonizing construction and enormous financial resources. This means leadership has to make massive investment decisions today for future market demand that won't actually materialize for another 3 to 5 years. Imagine trying to predict exactly how many cars will be on a specific highway 5 years from now, and having to build the exact number of lanes for that traffic today using billions of dollars in non-refundable cash. Getting that prediction wrong? It's incredibly costly.
These executives are trapped on a terrifying strategic tightrope. On one side, if you underestimate future demand, you face crippling shortages. Bottlenecks emerge, and you literally cannot give your hardware partners the chips they need. You leave billions on the table. But on the flip side, if you overestimate demand, the consequences might actually be worse. You're left with phenomenally expensive, multi-billion-dollar facilities operating way below capacity, just sitting there. That isn't just a loss of temporary profits, it's a massive company-destabilizing cash burn.
And to make matters infinitely worse, market demand didn't just grow, it skyrocketed exponentially. Our entire modern existence suddenly demanded more silicon. Cloud computing exploded as companies migrated their servers, gaming hardware surged, AI systems began their massive, resource-hungry ascent, requiring exponential compute power. Data centers expanded globally to hold up the internet, right alongside rapidly evolving consumer electronics. All of these fast-moving sectors demanded the most advanced chips simultaneously. It put unprecedented pressure on Intel's capacity planning. They were essentially tasked with supplying the entire digital revolution all at once. And right when demand peaked, the physics got infinitely harder. As transistors shrink to microscopic nanometer sizes, the technical difficulty doesn't just scale linearly, it goes completely through the roof. Maintaining high yield rates, which is basically the percentage of chips on a silicon wafer that actually work perfectly, becomes an absolute nightmare. At this scale, a single rogue speck of dust or a tiny vibration from a truck driving outside the factory can ruin a whole batch of chips. And bad yield rates mean you're literally throwing away millions of dollars of raw materials. Smaller, more advanced process technologies make production consistency so much harder to maintain. Scaling this kind of advanced manufacturing isn't just about throwing cash at a problem, it's about pure, flawless execution. And this is exactly where dangerous internal bottlenecks began to form.
Act 3. The rival strike. So what happens when execution slips? A technical delay rapidly turns into a strategic disaster through this brutal domino effect. It starts in months. A missed deadline suddenly gives competitors a little extra breathing room to improve their own tech. Then it bleeds into quarters. Because the global technology ecosystem relies on highly predictable chip cycles, a delayed processor means product launches across the whole industry, like a major laptop release slated for October, become impossible to coordinate. Finally, it stretches into years. Hardware partners get tired of waiting, customer confidence fundamentally weakens, and those rivals gain unstoppable momentum.
The resulting shift in the global landscape was nothing short of a psychological shock to the tech world. Intel went from having unquestioned dominance to suddenly facing a significantly weakened manufacturing advantage. Meanwhile, AMD, the company that had historically been the perpetual market underdog, stepped up to become a rising processor powerhouse. And TSMC, once just an emerging foundry, proved that outsourced manufacturing could actually beat vertical integration, cementing themselves as the advanced manufacturing giant we know today. The perception of the entire market completely flipped, and in the tech industry, perception strongly dictates both investor confidence and strategic positioning.
Act 4. The autopsy and the moral.
So, what are the strategic lessons here? Well, leadership in this space depends on far more than just designing great products. It requires manufacturing them reliably at scale. The story of Intel proves that in hardware, operational execution literally equals innovation. Brilliant ideas are practically worthless without flawless factory execution. We also learned that capacity planning mistakes don't kill you instantly, they weaken your advantage gradually over time. Long-term investment discipline is absolutely vital because you can never afford to pause your capital expenditure. Every single delay creates an immediate opportunity for your rivals to sprint through. And operational bottlenecks damage both your actual performance and how the market perceives your competence. If there's one thing you take away from this entire explainer, let it be this: operational capability itself becomes strategic power. Manufacturing speed, yield rates, and massive production scale are actual competitive weapons. They aren't just back-office operations to be managed on a spreadsheet. You simply cannot maintain leadership through historical success alone. You have to earn it every single day on the factory floor. Let's wrap up by leaving you with this provocative thought. Did Intel stumble because of one single bad decision or a gradual loss of execution? As we've seen, it wasn't one sudden disaster. It was a gradual, compounding loss of momentum under enormous uncertainty. It's a powerful reminder that in the world of high-tech manufacturing, gravity applies to everyone. Even the biggest industry giants will fall if they stop pedaling. Thank you so much for joining me to unpack this fascinating story. Keep questioning, keep learning, and I'll see you in the